Now, today we will see Lagrange's mean value theorem, that is LMVT. So, exercise 2.3 question number 7 is verify Lagrange's mean value theorem. For that we will see what conditions we have to verify. We have to see to verify the Lagrange's mean value theorem. Same LMVT, if f of x is a real valued function defined on the real value variable such that f of x is continuous in the closed interval ab. Second condition is f of x is differentiable on open interval ab, then there exists a real number c in an interval ab such that f dash of a is equal to f of a minus f of b minus f of a upon b minus a. Now see here, in Rolle's theorem, what was the third condition? F of a is equal to f of b. Here that condition is not there. First two conditions are same, and there in Rolle's theorem f dash of c was 0, and here f dash of c was f of b minus f of a upon b minus a. So in a given interval, first is a and second is b. So see the difference between Rolle's and LMVT. Remember the difference so you will understand it. So for LMVT, first two conditions are same. Third condition is not there in LMVT as Rolle's theorem, and f dash of c is equal to f of b minus f of a upon b minus a. Now question number 7 is verify LMVT for the given functions. So first function is given f of x is equal to log x on the interval 1e. So our 1 is a and this is b. So this is which type of function? This is a logarithmic function. So I will write now, say first two sentences same. F of x is continuous on closed interval 1e and f of x is differentiable on open interval 1e. So LMVT is applicable for the given function f of x. Now what is our f dash of c? F of b minus f of a upon b minus a. Now for that we will find f of a and f of b. So f of a is what? F of 1. So log 1, always remember log 1 is 0. Now what is f of b? B is e, the f of e, that is log e. Log e is 1. Now we want f dash of c also. So this is the formula for f dash of c. We need f dash of c. For that we will need f dash of x. So the f of x is log x. Then f dash of x is 1. Find the derivative of f of x. F of x derivative is f dash of x 1 upon x. Now you have to write there exists a point c for which formula f dash of c is equal to f of b minus f of a upon b minus a. Now f dash of x is 1 upon x. So f dash of c will be 1 upon c, and f of b is 1 minus 0 upon b minus a is e minus 1. Therefore 1 minus c is equal to 1 upon e minus 1. Take reciprocal, so you will get the value of c. C is equal to e minus 1. Now the given interval is 1 to e. We have to see that the c lies in that interval. So e minus 1, approximately the value of e is 2.7. So see our value of c is e minus 1. 2.7 minus 1, that is 1.7. So our interval is what? 1 to 2.7. So 1.7 lies in this interval. So e minus 1 lies in between 1 to e. So LMVT is verified. Next is second function is f of x is equal to x minus 1 into x minus 2 into x minus 3 on the closed interval 0, 4. Now first we will simplify this and take. So what we will do, f of x is equal to multiply these two brackets and this x minus 3 as it is. Now multiply x square minus 3x plus 2 x plus 3, again multiply this 2, we will get f of x. So simplified f of x is x cube minus 6x square plus 11x minus c. Now this is a polynomial function. This is a polynomial function. So for polynomial function we can write f of x is continuous on 0, 4 and f of x is differentiable on 0, 4. So two conditions are satisfied. So LMVT is applicable to the given function. Now next step is f of a. F of a, here a is 0. So f of 0 is equal to, substitute here 0. X cube means 0, minus 6x square means 0, 11x means 0, minus 6. So our value of f of a is minus 6. Now find out f of b. Our b is 4. Substitute in this f of x. You will get 4 cube minus 6 into 4 cube plus 11 into 4 minus 6. So f of b is also 6. Now we want f dash of c. For that we need f dash of x. So f dash of x is equal to, find derivative of this function, that is 3x square minus 12x plus 11. Now write down, there exists a point c for which, write down formula, f dash of c is equal to f of b minus f of a upon b minus a. Now what is our f dash of c? In f dash of x, substitute x is equal to c. So 3c square minus 12c plus 11. And f of b is 6 minus f of a is minus 6. So this becomes 6 minus 6 upon 4 minus 0. Then we want here to find the value of c. So now it becomes 3c square minus 12c plus 11 is equal to 3. Now this 3 take this side, 3c square minus 12c plus 8 is equal to 0. Now here we will use the formula method. By formula method, x is equal to b square plus or minus under square root sign b square minus 4ac upon 2a. So use the formula 12 plus or minus under square root sign 144 minus 96 upon 6. So simplify it, 12 plus or minus 48 upon 6. So 48 we can write 4 root 3. Now separate 12 upon 6 plus or minus 4 root 3 upon 6. That will become 6 1s are 6 2s are 2 plus or minus 2 plus root 3 upon 3. But our interval of x is 0 to 4. So now we have to check. Now here we got two values of c. Which are the two values? 2 plus 2 root upon 3 and 2 minus 2 root upon 3. Now verify that both values come in this interval. So our root 3 value is 1.73. So 1.73, put in this root 3, put root 3's value 1.73, verify and see that both the values of c come in the interval 0 to 4. Next one is third one. F of function is f of x is equal to x square minus 3x minus 1. Now here the function is a polynomial function. In the same way we will write function is continuous on the given interval, close interval, and f of x is differentiable on open interval. Now the conditions of LMVT are satisfied. Now we will find f of a. F of a, our a is minus 11 upon 7. So f of 11 upon 7 is minus 11 upon 7 bracket square minus 3 into 11 upon minus 11 upon 7 minus 1. So after calculating we will get value of f of a is 303 upon 49. Now we will find f of b. F of b means our b value is 13 upon 7. So f of 13 upon 7 is 13 upon 7 bracket square minus 3 into 13 upon 7 minus 1. Substitute the values, we will get minus 153 upon 49. Now f of x is equal to, find out derivative of the function, 2x minus 3. We want f dash of c. So f dash of c is 2c minus 3. Now there exists a point C such that, write down the formula, f dash of C is equal to f of B minus f of A upon B minus A. Now our f dash of C is 2C minus 3. F of B is minus 153 upon 49. Our f of A is 03 upon 49 upon B minus A, that is 13 upon 7 minus 11 upon 7. So say 2C minus 3 is equal to minus 456 upon 49 and 24 upon 7. So make it 7 reciprocal, minus 7 upon 24. So 2C minus 3 is equal to minus 19 upon 7. 2C is equal to minus 19 upon 7 plus 3. Therefore 2C is equal to 2 upon 7. This 2 gets cancelled. C is equal to 1 upon 7. Now you have to see our interval is minus 11 upon 7 and 13 upon 7. So does 1 upon 7 lies in this interval? So C lies in this interval. Therefore our LMVT is verified. See one more sum. See fifth sum from that only. F of x is equal to x minus 1 upon x minus 3 on the closed interval 4, 5. Now again this is a rational function. Upon is a rational function. So f of x is a rational function. Same you have to write f of x is continuous on 4, 5 and f of x is differentiable on the open interval 4, 5. So all the conditions of LMVT is satisfied. So now we will find out f of A. What is our A? 4. Therefore f of 4 is equal to, substitute here 4. 4 minus 1 upon 4 minus 3 is 3. And f of B is 5. So f of 5 is equal to 5 minus 1 upon 5 minus 3 is equal to 2. Now we want to find f of x, f dash of x. So how to find f dash of x? F of x is x upon 1 minus x minus 3. So here quotient rule here to use, that is u upon v. So x minus 3 into d dx of x minus 1 minus x minus 1 into d dx of x minus 3 upon x minus 3 bracket square. So x minus 3 derivative of 1 is 1. This minus x minus 3, and here also derivative of x is 1, and this x minus 3 bracket square. So x minus 3 minus x plus 1 upon x minus 3. So f dash of x is equal to, this x gets cancelled, minus 2 upon x minus 3 bracket square. So f dash of x we got. Now f dash of c means minus 2 upon c minus 3 bracket square. There exists a point C such that f dash, write down formula, f dash of c is equal to f of b minus f of a upon b minus a. What is our f dash of c? Minus 2 upon c minus 3 bracket square is equal to f of b is 2 and f of a is 3. 2 minus 3 upon 5 minus 4. So this minus 2 upon c minus 3 minus 1 upon 1, that is, we can write it that c, take reciprocal, c minus 3 bracket square is equal to 2. Therefore c minus 3 is equal to plus or minus root 2. Therefore c is equal to 3 plus or minus root 2. So here we got two values of c, 3 plus root 2 and 3 minus root 2. Now here value of root 3 is 1 minus root 3 is 1.4. So substitute here and see both, find out both the values of c and see that it comes in the interval 4, 5. So after verifying, 3 plus root 2 comes in the interval 4, 5 and 3 minus root 2 is not coming in the interval 4, 5. So our value of c is 3 plus root 2.